Good day class! Welcome to our online class. It's me, Teacher Edzon, your teacher in this session. Okay, now, before we start, I would like to assure that you are ready in your comfortable place so you can focus in our topic that we are going to discuss this day. So class, in checking our attendance, you just need to like this video so I can know that you already watched our lesson this day. For today's lesson, I'll be discussing the properties of waves. Transverse and longitudinal waves may be observed through the use of a slinky. A slinky is a helical spring that can be stretched and made to bounce up and down. If one end of a slinky is made up to move up and down, energy is transferred from the end. This energy causes the individual skull to be displaced upward and downward, creating a transverse wave. Recall that in a transverse wave, the particles of the medium move perpendicular to the direction of the wave's motion. If a longitudinal wave is desired, the slinky may be stretched out in a horizontal direction. The first coil of the slinky may be displaced, causing it to move in a direction parallel to the entire slinky. The individual coils of the slinky are displaced leftward and rightward. We are surrounded by different types of waves, both transverse and longitudinal. We see things because there is a light, a transverse wave, and communicate with others through sound because of longitudinal waves. To fully understand waves, scientists found a way to study them by identifying and measuring their properties. We have the wavelength, amplitude, frequency, and speed. Now, let's proceed to the first property, wavelength. One way to describe a wave is by its wavelength. And what is wavelength? Wavelength is the distance between two successive identical parts of a wave. It can be distance between two consecutive crests or two consecutive troughs of the transverse wave. The wavelength of a longitudinal wave is a distance between two consecutive compressions or two consecutive refractions. Wavelength is denoted by the symbol lambda and measured in meters. Wavelength is an important property of a wave. In visible light, the wavelength determines its color. The difference between red light and violet light is that they have different wavelengths. The wavelength of a red light is longer than that of violet light. Some electromagnetic waves like X-ray have shorter wavelengths than microwaves as shown in this figure. Next, let's proceed to amplitude. Some waves are high while others are low. The height of an ocean wave indicates the amount of energy it carries. In this figure, it shows the tsunami that devastated Japan after an earthquake. You can figure out how waves can destroy anything that stands in their path. A wave is a high amplitude has more energy than a wave with low amplitude. And amplitude is the greatest displacement of particles of a medium from the rest position. It is a measure of the energy that waves carries. For example, a strong wind in a beach creates larger water waves than a gentle breeze. The amplitude of a transverse wave is measured of the distance from the rest position to a crest or a trough. The amplitude of a longitudinal wave is measured of how compressed its medium is. The more compressed the particles are, the greater amplitude. Next, let's proceed to frequency. Frequency is the number of waves that passes a group point in a certain amount of time. For example, suppose you are on the beach watching waves that roll towards the shore. If the waves reaches the shore every 15 seconds, then you can say that these are low frequency waves compared to the waves that reach the shore every 5 seconds. Frequency is measured in a unit called Hertz, named after the German physicist Heinrich Hertz, who discovered radio waves. 1 waves per second equal 1 Hertz. Notice the waves with long wavelengths have low frequency and wavelengths with high frequencies have shorter wavelengths. Our eyes can detect light with frequency ranging about 4.3 times 10 raised to 14 Hz to 7.5 times 10 raised to 14 Hz. Light in this range is called visible light. The difference of the frequency in a visible light waves accounts with the different colors we see. The other electromagnetic waves exist at a frequency lower or higher than the frequency of the colors of visible light. Thus, we cannot see them. Electromagnetic radiation and different wavelengths and frequency is shown in electromagnetic spectrum. The frequency of the sound determines its pitch. A high pitch sounds correspond to high frequency and vice versa. Some sounds cannot be detected by human ears because they are beyond the range of human perception. The range of frequency of sounds audible to the human is 20 to 20,000 Hz. A dog may hear a sounds that you cannot hear. Dogs can hear sounds with a frequency as low as 45 Hz and sounds with a frequency as high as 45,000 Hz. So that's all for our lesson this day. Hope you have learned something from it. Thank you!